Identify the Bronsted-Lowry acids and bases on both sides of the equation. Reactants side. Formic acid, HCOOH, acts as the proton donor, acid, while the chloride ion, ClO2 to the power negative, acts as the proton acceptor, base. Product side. Chlorous acid, HClO2, acts as the conjugate acid, capable of donating a proton in the reverse reaction, while the formate ion, HCOO to the power negative, acts as the conjugate base, capable of accepting a proton in the reverse reaction. Interpret the thermodynamic meaning of the equilibrium constant, KEQ less than 1, and equilibrium constant of less than 1, KEQ less than 1, indicates that the reactants are favored at equilibrium. This means that under equilibrium conditions, the concentration of the reactants, ClO2 to the power negative and HCOOH, is significantly higher than the concentration of the products, HClO2 and HCOO to the power negative. Apply the fundamental rule of acid-base equilibrium. In any Bronsted-Lowry acid-base reaction, proton transfer equilibria always favor the side of the reaction with the weaker acid and the weaker base. This occurs because stronger acids have a greater tendency to lose protons, and stronger bases have a greater tendency to attract protons, reacting highly efficiently to produce their more stable, weaker counterparts. Determine the relative acid strengths. Since the reactants are favored at equilibrium, the reactant acid, HCOOH, must be the weaker acid, and the product acid, HClO2, must be the stronger acid. Acid strength. HClO2 greater than HCOOH determine the relative base strengths. Since the reactants are favored at equilibrium, the reactant base, ClO2 to the power negative, must be the weaker base, and the product conjugate base, HCOO to the power negative, must be the stronger base. Base strength, ClO2 to the power negative less than HCOO to the power negative. Note: this perfectly aligns with conjugate acid-base theory, which states that a stronger acid, HClO2, must conjugate to a weaker base, ClO2 to the power negative, and a weaker acid, HCOOH, must conjugate to a stronger base, HCOO to the power negative. Select the matching option, combining these two relative strengths, acid strength. HClO2 greater than HCOOH and text base strength. ClO2 to the power negative less than HCOO to the power negative. Identifies option D as the correct answer. The correct answer is option D, acid strength. HClO2 greater than HCOOH. Base strength. ClO2 minus less than HCO minus.